Okay, so the first one here we are multiplying. I'm going to do the 3 point, sorry, my pen work maybe. .72 on top and 4.5 on bottom. We do not have to line up the decimal points because when we multiply and divide, we don't have to have the same name. When I multiply, I generally put the number with the most digits on top. So the 5 times 2 is 10. So that is a 0, carry a 1. 5 times 7 is 35. Plus the 1 is 36. So that's 6, carry the 3. 5 times 3 is 15. Plus 3 is 18. So 8, we carry over the 1. Now, before we move over, we do fill in our 0 down here. And I'm going to put a line up here so I know that those are old carries. So now 4 times 2 is 8. 4 times 7 is 28. And there's nothing above the line, so there's nothing carried. So 8, carry the 2. 4 times 3, 12. Plus that 2 is 14. So we add, we've got 0, 14, carry the 1. So that's 16, 17, carry the 1, 6, and 1. Now people ask, do I have to write this 0 here? And the answer is for now, yes, we do, because it's going to help us figure out where our decimal point goes. Where does the decimal point have to go? Between the 6 and the 7. How'd you get that? Okay, in the problem, there's 1, 2, 3 decimal places in the problem. So we have to put 1, 2, 3 decimal places in the answer. We had to keep that 0 there, so we placed that decimal point correctly. Now, like I said, we can double check this pretty easily by using just a little quick estimation. This is about 4. This is about 5. 4 times 5 is about 20. That tells me I put my decimal point in the right spot because 1.6 wouldn't make any sense and 167 wouldn't make any sense. Number 2. Got the 51.4, and I'm going to subtract 9.836. The decimal points have to line up. When we add or subtract, we must have the same name. And the way we keep the same name is by, or make sure they have the same name, is by lining up those decimal points. So now I fill in those missing zeros, and I go to subtract. 0 minus 6 can't be done. We need to borrow. Nothing here to borrow from, so we go over to here. This becomes a 3. That would make this a 10. We borrow again. This is a 9, and now this is a 10. Now we can subtract 10 minus 6, 4. 9 minus 3, 6. 3 minus 8. Got to borrow. Makes that a 0, and this is 13. 13 minus 8. 5, and then we can't cross the decimal point. We bring the decimal point straight down. 0 minus 9, we're going to borrow. That's 4 and 10. 10 minus 9, 1, and then the 4. Any questions on that one? Or these are the first two? Okay. Number 3 is simple addition. I have the 63.84. I'm going to put the 9.4 underneath it. Putting my decimal point lined up again. I should add my missing 0 here to fill this out. So now then, 4 plus 0 is 4. 8 plus 4. 12. So 2 carry the 1. Before I can do the 1, 3, and 9, I need to the decimal point. Good. 1, 3, and 9 makes 13, so 3 carry the 1, yep. And then 1 and 6 is 7. Any questions there? Okay. Finally, the division. Well, 83.62 divided by 5.1. What are we going to turn that into? First of all, we're not going to divide by 5.1. We're going to divide by 51. So what's going to go inside the division? Careful. 836.2. We only went one place value here. We only go one place value there. Remember, you can think of it as the fraction. We're multiplying top and bottom by 10 to move that decimal point over. So we go to divide. Let's say I want this to the nearest hundredth. So 51, does that go into 8? No. So we'll leave a blank above the 8. 51 into 83. How many times? Once. 1 times 51 is 51. We'll subtract. 3 minus 1 is 2. 8 minus 5 is 3. Now I should double check to make sure, is this smaller than this? Yes, it is. So we know we're okay. Now I'm going to bring down the 6, the next digit. 51 into 326. 6 times, okay. So 6 times 1 is 6. 6 times 5 is 30, so it's 306. We subtract. 6 minus 6 is 0. 2 minus 0 is 2, and 3 minus 3 cancels out. So we got 20. Before I can bring down the 2, what do I have to do here? To bring up that decimal point. I can't cross the decimal point. The only operation where I can cross the decimal point is multiplication. So I bring down the 2. 51 into 202. Well, 4 times 51 would be 204. So we have to do 3. 3 times 51. 3 times 1 is 3. 3 times 5 is 15. To subtract here, this will be a 1 and a 10. We borrow, that's 9 and 12. 12 minus 3 is 9. 9 minus 5 is 4. So we've got 49. There's no more digits up here, so are we done? No. 1 to the nearest hundred, so we're going to add a 0 and bring it down. 51 into 490. 5 times 51 is 455. Sorry, not 5. What needs to go there? 9 times 51 is 459. I subtract. This is going to be 8 and 10. 10 minus 9 is 1. 8 minus 5 is 3. Are we done? We're at the hundredths digit. We always have to go one past where we want to be. So I'm going to add another 0 and bring it down. 51 goes into 310 6 times. This is the reason why I had to add that 0, because now to the nearest hundredth, that 6, that we had to have that next digit to tell us that this rounds up. Well, this is actually going to round up to 16.40. Now, there's a long discussion as to, do I need that 0 there, or could I just do 16.4? Well, I said I wanted it to the nearest hundredth. Putting that 0, I mean, numerically, to take the 0 off, it doesn't change anything. But As far as the measurement is concerned, I need that 0 there to indicate that I did go to the nearest hundredth. Any questions so far? Okay, and then we have convert that 8.72 to the nearest, or to a fraction. So what do I do? There's two parts I'm going to work with here. Tell me what to do. What do I do with the part before the decimal point? That is just my whole number. That's going to stay. Now I've got the 72 afterwards. That's 72 over what? Hundredth. Because this is tenths, hundredths. That's 72 hundredths. The other way you can remember, a little bit of a shortcut. There's two decimal places here. There better be two zeros in that denominator. So now I'm not going to leave it as 72 over 100, because both of those can be divided by 4. It's going to be 18 over 25. So it is 8 and 18/25. Did anybody have all 5 of those right before I did them? A few of you? The rest of you just needed more time, I'm guessing? Okay. So we have our operations with decimals. The next step, just like we do with the fractions, is we can add multiple operations with them. We might have 7.8 minus 2.1 times 3.4 plus 1.2 to the third power. With something like this, where would I have to start? Okay, excellent. We go through our order of operations. There are no enclosing symbols, so we don't worry about any parentheses or anything. So its exponents are the next thing on our list. What is 1.2 to the power of 3? Perfect, 1.728. So we take out the 1.2 to the third power, we replace it with 1.728. Now, what's our next step then? What's the next operation we have to perform? Multiplication. Perfect. Now, we can either do that as a negative 2.1 times 3.4, or we can do it as 2.1 times 3.4 and it's subtracted later. We're going to do it as being subtracted later, just because that's a little bit easier for us. So, what is 2.1 times 3.4? $7.14? So it's 7.8 minus 7.14 plus 1.728. Yes. Yep. On that, there's an SD key on that calculator. Hit that, it should turn into a decimal. Okay. You bet. So now we've got addition and subtraction, so we are going to go left to right here. We've got 7.8 minus 7.14 is 0.66. We add that with the 1.728, that's going to be 2.388. Is that what you guys got? Perfect. I'm going to have you guys try a couple of these in your notes. Try that one and we'll talk about it in just a minute. Bless you. So to solve this, we got to do everything on top first. What's our first step on top there? The exponent. So 2.4 squared is 5.76. Good. Then what? Subtract 3.1, which gives us 2.66. So the top becomes 2.66. What's our next step? We're going to subtract the bottom. 3.9 minus 1.24 is 2.66. And then we divide. 2.66 divided by 2.66 is 1. So it all comes out to 1. Any questions there? So I want you to try this one in your notes quick. We'll talk about it in just a second. So we have parentheses here, so obviously we're going to start there. In the parentheses, what do we need to do first? Multiplication, good. What is the 1.8 times 2.3? 4.14, good. So then what? Well, we got to go left to right. It's all addition and subtraction in the parentheses. So we go left to right and subtract. 6.4 minus 4.14 is 2.26. And then we finish off the parentheses. We add those together. That is 3.66. We're down to a single number in the parentheses, so I can get rid of the parentheses. I have to remember to put in the multiplication there. Now the parentheses are gone. What is next? The 2.1 times 3.66, which is 7.686. Is that right? Okay. Then what? Okay, it's all addition and subtraction, so we will go left to right. 5.7 plus 7.686 is going to be 13.386. And then we will subtract the 4.7. 13.386 minus 4.7 is 8.686. Any questions? Well, our next logical step with this is to move on to expressions. We've had expressions like 7b minus 3p over m plus q squared. And we've evaluated them for things like b equals 8, p equals 4, m equals 2, and q equals 5. How did we handle that? What did we do there? Put the numbers in. So 7b becomes 7 times 8. b is 8, so 7b is 7 times 8. Minus 3p over m becomes 3 times 4 over 2. Good. P is replaced with the 4 and m is replaced with the 2. Plus q is 5, so it becomes 5 squared. Good. Now we're back to our order of operations. What do we need to do first? Exponent. 5 squared is 25. Now, next, we've got 7 times 8 is 56. Now, technically, we could have thought of that as an enclosing symbol. We could have done the numerator of that earlier. We didn't have to. It'll still be okay. But we're going to do the numerator now. 3 times 4 is 12. And now, let's get back here. Now we need to divide that. 12 divided by 2 is 6. What's next? So 56, it's all addition, so it's left to right. 56 plus 6 is 62. Plus 25 is 87. Well, it's the exact same process when we have decimals involved. Let's have 4.5m minus 3p over x. I want you to evaluate that for m equals 6.2, p equals 2.1, and x equals 0.3. I'll give you a few minutes to evaluate. Tell me where to start. Fill in the blanks, okay? So what does it become? Perfect. So 4.5m becomes 4.5 times 6.2. 3 times p becomes 3 times 2.1, and x is 0.3. What's next? I can multiply 4.5 times 6.2 is 27.9. Good. Now over here in the fraction, I have multiplication and division to do. Remember, this is kind of like an enclosing symbol. I have to do the top first. What is 3 times 2.1? 6.3. Good. Now I can divide 6.3 divided by 0.3. 21. And we subtract to get 6.9 is our answer. Very good. Any questions there? Okay. So, working with these decimals is the same as working with whole numbers. We can do everything else with them. It's just a little uglier because we got to do the calculations with the decimals. I'm kind of like with the fractions that made things worse. Well, just like we do the fractions, we're going to move on to doing things like this. 3.5x plus 7.5 equals 18. To solve this equation, where would I start? We subtract 7.5 from both sides. So yes, over on the left side, we have 3.5x left. On the right side, 18 minus 7.5 is 10.5. And then divide by 3.5. We get x equals 3. Very good. They don't all come out quite that neatly. We might have 1.4x. Come on. 1.4x minus 3.1 equals 5.7. What are we going to do here? We're going to add the 3.1. Good. What do we get? 14.x equals 8.8, or 1.4x equals 8.8. And then we divide by 1.4, which gives us x equals 6.285714,286 approximately. What's that tell us? Obviously, we probably don't want to leave that many decimal places. So we need to know where to round it. If the problem doesn't tell you where to round it, in my math lab, it'll always tell you where to round it, pretty much. But if it doesn't tell you where, round to one decimal place beyond the problem. What's that mean? Well, in this problem here, how many decimal places does every number have? 1 is the most number of decimal places any number has in that problem. So we're going to round to 1 decimal place beyond that, which would be 2. So that'd be 6.29 is where we would round. Again, my math lab is always going to tell you where to round. So I'm going to have you guys try one in your notes. (2.8x plus 3.2 equals 8.8). We'll talk about this in a minute. Looks like everybody's pretty close to done. What's the first step? Subtract 3.2. So we get 2.8x equals 5.6. And then divide by 2.8 gives us x equals 2. Any questions on that one? Okay then. Well, let's move on to something like this. 4.6x plus 3.4 minus 2.5x equals 6.2. What's different here? The x appears twice. And whenever that happens, we have to get it down to the variable only appearing once before we do anything to solve it. So here, do we have to get rid of one or can we combine them? They're both on the same side of the equation. There's my equal sign. They're both on the left side. So we can just combine them. We're combining 4.6x and it's a negative 2.5x, which makes 2.1x. Very good. We still have the plus 3.4 equals 6.2. What are we going to do with that? Subtract 3.4. So that's gone. We have 2.1x equals 2.8. And then divide by the 2.1. X equals 1.333333. Any questions? Okay, in your notes, I'm going to have you guys try one. Give that one a shot. We'll go over it in a minute. So what do we have to do first? Combine the x's. 1.3 and 1.5x make 2.8x. So 2.8x minus the 2.5 equals 7.1. And then add the 2.5, yes. So 2.8x equals 9.6. Come on. And then divide by 2.8 gives us that x equals 3.428574143 approximately. So where would you round that? 3.43. Nothing in the problem goes past one decimal place, so we'll round our answer to 2. What about if we run into something like this? Actually, let's make this 5.3, make it work a little easier for me. What's different here? Yes, the variable appears twice still, but this time it appears on each side of the equation. What does that change about how we have to handle it? Yeah, we can't just combine them anymore. We have to get rid of one of them. So to do that, I have to subtract one. Which one do I want to subtract? The smaller one, which will be 7.1x. So we subtract that, and it's gone. We have to make sure we subtract it from the other side as well. So 8.5x minus 7.1x is 1.4x minus 4.1 equals 5.3. What's next? Add the 4.1. So 1.4x equals 9.4. And then divide by 1.4. So x equals 6.714285571. So we round that to what? X equals 6.71. Perfect. One for you guys to try. I'll give you a minute to try that one, and we'll talk about it here in just a little bit. Where do we start? Subtract the 5.4x from both sides. There we go. So we get 3.2 equals 2.1x minus 3.7. Then what? Add 3.7. Good. So 6.9 equals 2.1x. And then we will divide by 2.1. So we get, what is that? X equals 3.28574143. So we're going to list that as what? 3.29. Okay, it's about that time for break. It's 4:19. Let's take our break, come back at 4:29. During break, there's a great discussion going on one of the homework questions. So I wanted to make sure we had that wrapped up. Did you guys figure out what you needed to on the homework question? On which is that homework 15 due for today? So let's take a look here. Number 30. That can't be the one. Okay. What was the question about? Can you? It was number 8. Okay. Perfect. So let's take a peek here. Okay, so we got the perimeter of a rectangle. So your numbers are probably different than mine, but perimeter of a rectangle is 60 inches. The length is 9 inches less than double the width. What are the dimensions of the rectangle? So perimeter is 60. So what we have here, perimeter equals 60. We have the rectangle has a length and a width. And it says that the length is 9 inches less than double the width. So 9 inches less means we're subtracting 9 from something. We're subtracting it from double the width, 2W. So the width we're going to leave as W. The length we're going to change to 2W minus 9. Our formula, perimeter is 2L plus 2W. We've already got the 60 for the perimeter. It goes in for P. 2L is going to become 2 times 2W minus 9 plus the 2W just stays 2W. Now we just have to solve the equation for W. So we're going to multiply the parentheses there. 2 times 2W is 4W. 2 times negative 9 is negative 18. Now we can combine some like terms on the right side there. 4W and 2W make 6W minus 18. And we're just going to solve the equation now for W. So we'll add 18. So 78 equals 6W. And we will divide by 6. So 13 equals W. So 13 is W. L then is 2W, or 2 times 13 minus 9. 2 times 13 is 26. Minus 9 is 17. So that would tell us that others asking for the expressions. So the length of the rectangle, W is the width and 2W minus 9 is the length. So I guess I did way more work than I had to, but there we go. Which of the equations below is the correct equation? Well, 2W plus 2 times, that's not it. 2W plus 2 times 2W, that one would be the correct equation. And then solve for the width was 13 and the length was 17. Is that more clear, or do you want me to go back through that? Perfect, okay. The key is being able to remember to express one of them in terms of the other. In this case, in most cases, you're going to be expressing the lengths in terms of the width. Don't be afraid to yell at me if you have questions like that you want to go over. I do hear you guys discussing them, but part of the time I enjoy listening to you guys reason through it as a group, so I just let you talk. Okay, so on with the show here. If my pen will work. There we go. Okay, so we've dealt with these equations with decimals. There's one more step that we can take it, and that would be to look like this. 3.2 times 4.5x minus 1.5 equals, oh, let's do 9.6. What do we have to do here? We have to multiply the 3, distribute the 3.2, multiply the parentheses. So what is 3.2 times 4.5x? 14.4x, good. And then 3.2 times negative 1.5. Negative 4.8 equals 9.6. What's next? We're going to add the 4.8 to make it go away. So I've got 14.4x equals 14.4. And then divide by 14.4. X equals 1. I'm going to have you guys try one. So 2.5 times, and in parentheses, 3.6x plus 1.4 equals 15. I'll have you go from there. We'll talk. Walk me through it. Okay, so 2.5 times 3.6x. 9x, good. 2.5 times 1.4 plus 3.5. Then what? Subtract the 3.5. Gives us 9x equals 11.5. Then we have to divide by the 9. X equals 1.7777. So that'd be 1.78 is where we would round that. Or if I wanted to make that with decimals, when something keeps repeating like this, what's our notation for it? 1.27, that's what I thought. 1.27777, right? Okay. But either way, We've got that 7 that keeps repeating there. How do we express that? Well, we put a bar over it. That bar tells us that 7 keeps repeating. This is referred to as a repeating decimal, and it happens a lot. We might have, let's say 5. 5 divided by 7, what are we going to get? 0.71428571428571428. So it's not just a single digit. Up here, it was just the 7 that repeated. Down here, it's a series of 6 digits that repeats. 714285, and then it starts over again. So we can express that as 0.714285 with the bar over those digits. How about 5 divided by 6? What do we get? Yeah, 0.83333. So the 8 doesn't repeat, it's the 3s that come after it that repeat. Well, that notation isn't so difficult, but the difficulty would be, what if I have a decimal? What if I give you a decimal that repeats, and I tell you that all repeating decimals can be turned into fractions? So 0.4 repeating is a fraction. It can be turned into a fraction. The question is how? Well, this procedure isn't simple, but it involves our equations with decimals in it, like we've been doing here. We're going to start out by letting x equal 0.4 repeating. Now, of course, that 0.4 repeating is 0.444444444 going on forever. How many digits repeat? So step 1 was let x equal the decimal. Step 2, how many digits repeat here? Well, it's just the 4, right? Just 1 digit repeating. Up here it would have been 6 digits repeating. Here it's only 1. So the answer is only 1 digit repeats. Since only 1 digit repeats, we only have to move the decimal point 1 place. How do we move a decimal point 1 place? Times 10, multiply or divide by 10. So what I'm going to do is this. I'm going to multiply both sides of this equation by 10. What is x times 10? 10x. 0.444444 times 10 is 4.444444. So it's 4 point, and the 4 is still repeating. What does that do for me? Well, my step 3, so this was my equation step 1, this is step 2, is to subtract the equation in number 1 from the equation in number 2. What's that mean? I'll take my 10x, equals 4.4 repeating. And remember, we can subtract the same thing from each side, right? So I am going to subtract 0.4 repeating from this side. What does that do? Well, it cancels out. All these 4s here cancel out. They're gone. What's left over here is 4. I'm going to subtract 0.4 repeating from the other side as well. But we know that 0.4 repeating equals x, so I'm going to subtract x instead. It's the same thing. That'd be the difference of subtracting 1/2 and 0.5. They're the same thing, they just look different because x equals 0.4. So 10x minus x is 9x. So then, to solve for x, we're going to divide by 9. X equals, now I'm just going to reduce this as a fraction. 4 divided by 9 is just 4/9. 4/9 is the same as 0.4 repeating. Obviously, we're going to do a couple more examples of this. So let's take a look at this. Let's deal with 0.7 repeating. What's my first step? Let x equal the decimal, right? My second step depends on how many digits repeat. How many digits repeat here? Only the 1. So that means I'm going to multiply by what? 10. So x times 10 is 10x. 0.7 repeating times 10 is 7.7 repeating. What am I going to do next? I'm going to take this equation and I'm going to subtract this equation. So I'm going to subtract the 0.7 repeating on the right side, and I'll subtract the x on the other side. 10x minus x is 9x. 7.7 repeating minus 0.7 repeating is 7. So then I'm going to divide by 9 to get x by itself. X equals 7/9. Perfect. We're going to change it up a little bit. How about 0.27 repeating? What's our first step? Yeah, x equals 0.27 repeating. What's our second step? Well, it's not times 10. How many digits repeat here? There's 2 digits to repeat. So it's going to be times 100. You had the right idea. I know what you're thinking. So 100 times x is 100x. 0.27 repeating, bless you. 0.27 repeating times 100. The reason we had to do times 100, we have to go 2 digits. So that's now 27.27 repeating. Why? Because we multiplied by 100? Because this is, yeah, 0.27272727. So when we multiply by 100, it moves the decimal. I'll get the system back up. So it just moves that decimal 2 spots. So, okay. Come on, restart. There we go. Okay, so that's still being slow coming back up. So now we have in our third step, we're going to subtract this equation, or take this equation, 100x equals 27.27 repeating. And we're going to subtract that first equation, x equals 0.27 repeating. So 27.27 repeating minus 0.27 repeating is just 27. 100x minus x is 99x. Now to solve for x, I need to divide by 99. So x equals 27 divided by 99 is 27 over 99. But of course, that fraction can be reduced. Both of those numbers can be divided by 9. 27 divided by 9 is 3. 99 divided by 9 is 11. So 0.27 repeating is 3/11. You just put in 0.27 several times to do it? Okay. Okay, it should be just 27 divided by 99. The 0.27 canceled out here. There you go. That's okay. I'm going to have you guys try one on your own now. .864 repeating. See what happens when you try that one. Okay, so we will start out with x equals 0.864 repeating. What are we going to multiply by here? 1,000, because there's 3 digits that repeat. So that gives us 1,000x equals 864.864 repeating. So now we take that second equation, 1,000x equals 864.864 repeating. And we are going to subtract from it x equals 0.864 repeating. So over here, the 0.864s cancel out. We have 864. Over here, 1,000 minus 1 is 999x. We divide to get x by itself. X equals 864 over 999. Can that be reduced? Yes, both of those numbers can be divided by 9. So we get what, 96? Yeah, that works. You get 96 over 111, which still can be divided by 3. Which gives us 32 over 37. So 32/37 is equivalent to 0.864 repeating. I'm going to throw a little twist in here, give you something to think about. What if this is 0.736, but only the 36 is repeating? Well, here's what we can do. We're still going to start out as x equals 0.736 with the 36 repeating. But we have to add a step in here. We have to get that the repeating part by itself. So we need to move the decimal over to here so the repeating part is after the decimal. What do we do to do that? Times 10. So we get here, we multiply both sides by 10. We get 10x equals 7.36 with the 36 repeating. That's going to be our first equation. Now our second equation still goes off of how many digits repeat. How many digits are repeating here? 2, 3, and the 6. So we're going to multiply by what? 100. That moves the decimal 2 spots. This will be 736.36 repeating. Over here, 10x times 100 is 1,000x. So we take that second equation. 1,000x equals 736.36 repeating. And we still subtract this equation here. So we'll subtract 10x from this side. From this side, we're going to subtract 7.36 repeating. 1,000x minus 10x is 990x. Over here, the 0.36 repeating cancels out. 736 minus 7 is 729. And we finish up by dividing by the 990. So x equals 729 over 990, both of which can still be divided by, I know they can be divided by 9. It's going to be 81 over 110. And that's about it, isn't it? So 0.736 with the 36 repeating is equal to 81 over 110. I would never do something quite that difficult. I'm feeling a very, very deflated room right now, so I think we're going to call her a night. There is a new quiz due for tomorrow. That's Friday at 11:59 p.m. And there will be a new homework due for class time next Tuesday. We have 20 minutes. I'll let you guys have time. If you want to start the homework or the quiz, I'll be here till 5:20. Otherwise,